welcome back to our YouTube channel. Today we will start amines. In amines, our sequence will be, first we will discuss the method of preparation of amines. After that, we will discuss the chemical reactions or the chemical properties of amines. Amines is basically defined as the derivatives of ammonia. Amines is basically defined as the derivatives of ammonia. That means one or more hydrogen of ammonia NH3 is replaced by either alkyl group or phenyl group. One or more hydrogen of ammonia is replaced by either alkyl group or phenyl group. Okay, let us define amines. Let us define amines. It is the derivative. It is the derivative of ammonia. It is the derivative of ammonia NH3. Derivative means simply one or more hydrogen of ammonia is replaced by either alkyl group or phenyl group. Let us take an example. If NH3 is ammonia, if one or more hydrogen of ammonia is replaced by either alkyl group and phenyl group, then it will be called 1 degree amine, primary amine, 2 degree amine, secondary amine, 3 degree amine, or tertiary amine. Okay, if we replace one of the hydrogen of ammonia is by alkyl group, if one of the hydrogen of ammonia is replaced by one of the alkyl group, it will be called 1 degree amine. If two hydrogen is replaced by two alkyl group, it will be called 2 degree amine. If all of the hydrogen is replaced by alkyl group, 3 alkyl group, then it will be called 3 degree amine. In the same way, if hydrogen is replaced by either phenyl group or alkyl group, it will always be 1 degree, 2 degree, 3 degree, and so on. Okay, let us start from our method of preparation. Method of preparation of amines. Our first heading will be, in method of preparation, our first heading will be the reduction of nitro compound. Reduction of nitro compounds. Nitro compound either containing alkyl group or phenyl group, or you can say alkyl, phenyl or aride. It is a nitro compound which is reacted with lithium aluminum hydride, LiLH4, or H2Ni, or metal plus acid. Like metal plus acid, we can take examples as Sn plus HCl, Fe plus HCl, Zn plus HCl. And the reaction is reduction. That means oxygen is removed and hydrogen will be added. That means our product will be either alkyl group or aryl group with NH2. That means basically our reaction is reduction. As we know that reduction is the removal of oxygen. Removal of oxygen and the addition of hydrogen. Let us see the mechanism, how the reaction proceeds. Our nitro compound is converted into basically 1 degree amines. The proposed mechanism will be, as we know from the hydrocarbons, lithium aluminum hydride is a source of H minus, which is a nucleophile, and we also have earlier seen in hydrocarbons H2Ni, that as a catalytic hydrogenation, which is used to convert alkyne into alkene and alkene into alkane. Basically, we are here see to the mechanism with metal plus acid, and we know that all metals are electropositive in nature. That means it will release H plus. Metal will release electron and it will form cation. With and acid will release H plus. That means if we simply take SN, Fe or Zn as a metal, let us suppose metal is electropositive in nature. That means it will form cation plus it will lose electron. Okay, if we take acid, the acid will also release H plus, acid will release H plus and Cl minus. We know H plus and electron. H plus takes 1 electron. H plus and electron will form hydrogen. H plus and electron will form hydrogen. Basically, the mechanism here is, if we take nitro compound, let us suppose nitrobenzene. This is the examples of nitrobenzene. At first, nitrobenzene, we will take 2 hydrogen. The 2 hydrogen will added like that. First we will break the bond between nitrogen and oxygen. 1 hydrogen and 1 hydrogen. The intermediate seems like that. And double bond OH and H. Basically, both the oxygen will be added to both the hydrogen will be added to the oxygen. Both the hydrogen will be added to oxygen and water will be removed. And the product will be nitrosobenzene. And double bond O. In the next step, we will again add 2H. After that, the 2 hydrogen will be added like H or H, and the product will seems like that. NH and HOH. In the next step, again 2 hydrogen is added. On 1 hydrogen is on nitrogen and 1 hydrogen in the oxygen, and product will be formed as like our aniline. Here 1 water molecule is also released. H2O, 1 molecule of water is also released. So this is the first method of preparation of amine from nitro compound. You just only go through the basics of the reaction. That means the reaction is the reduction. That means oxygen is removed and simply hydrogen is added. Okay. Our next reaction is the ammonolysis of alkyl halide. Our next method of preparation is ammonolysis of alkyl halide. That is, ammonia is reacted with excess of alkyl halide, in which the major step is the nucleophilic substitution reaction, which is SN2. Our second method of preparation of amines is ammonolysis of alkyl halide. Ammonolysis of alkyl halide. Ammonolysis of alkyl halide. Our second method of preparation of amines is the ammonolysis of alkyl halide, in which nucleophilic substitution SN2 reaction is a major step. In this reaction, generally we get a mixture of amines like 1 degree, 2 degree, 3 degree, and in the last we will get quaternary ammonium salt. Quaternary ammonium salt. For exam related purpose, this is not so important. The reason is we get a mixture of amines. We have to separate 1 degree, 2 degree, 3 degree amines. Okay? At first ammonia is reacted with ammonolysis. That means ammonolysis stands for reaction of ammonia in the presence of alkyl halide. Reaction of ammonia in the presence of alkyl halide. Alkyl halide. In this reaction, we will take alkyl halide in the excess. We will take alkyl halide at excess. In the first step of the reaction will be SN2. The reaction will be SN2. That means due to difference in electronegativity, this will be del plus and del minus. We know halogens are more electronegative, and we also know going from left to right in the periodic table electronegativity increases. So halogens is del minus and alkyl groups are del plus. In the first step, NH3 act like as a nucleophile. The nucleophile will take from the back side. And the product will look like R, N, H, and H. Nitrogen donates in ammonia. Nitrogen donate their lone pair, so there will be acquired a positive charge. And the nucleophile attack the leaving group X minus will departure. In the next step, halogen X minus donate electron to H plus, and the shared electron will donated to nitrogen, and product will be RNH2. That means 1 degree amine. That means the product will be 1 degree amine. As we have already said it earlier, the alkyl halide is in excess. That means the 1 degree amine form is further reacted with alkyl halide. And the next step, the product will be 2 degree amine. In the next step, the alkyl halide again reacted with the 1 degree ammonia. And mechanism is same like SN2. Here the next step, second step of the reaction is the acid-base reaction. And the eliminated product is HX, H minus X minus donate electron to H plus, and the product eliminated is HX. Okay. Next step of the reaction is as nitrogen donate lone pair to the alkyl group, there will be a positive charge, as like in the case of ammonia and in the presence of alkyl halide. Here the product will looks like RNR H, as nitrogen donate their lone pair, so it acquires positive charge. As the reaction is SN2, the leaving group departs from a shared electron pair. In the next step, X minus donate 2 electron, and the shared pair electron will go to the nitrogen, and the product will be at first HX will be eliminated, and product will be R and H. That means the product is 2 degree amine. This is also act as a nucleophile for the next alkyl halide. The reason is we have taken alkyl halide in excess. That means the 2 degree amine form is further reacted with alkyl halide. It will donate lone pair to alkyl, and in the again halogen is removed as a leaving group. Now nitrogen acquires positive charge because it donates lone pair to alkyl halide. That means the product will looks like, it's not the final product, R, and the nitrogen acquires positive charge. In the next step, X minus again donate electron to H plus, and the shared electron will move towards the nitrogen, and the product will be R and R, that is 3 degree amine. In the next step, as we have already said that the alkyl halide is in excess, that means 3 degree amine is further reacted with alkyl halide because it also present have lone pair. That means it act as a nucleophile. It further reacts with alkyl halide to form quaternary ammonium salt. It again acts as a nucleophile, donate electron, and X minus is not released from the quaternary ammonium salt. The product will look like R, and nitrogen will get positive charge, and this is called as quaternary ammonium salt. Okay. Quaternary ammonium salt. This is not a usual method to prepare the amines, because in this reaction we get 1 degree amine, 2 degree amine, and 3 degree. There is a mixture of amines is formed. Okay. In the next step, if you have given ammonia and generally ask the number of moles of alkyl halide to form quaternary ammonium salt, then the number of moles of alkyl halide will be 1, 2, 3 and 4. That means you can say that from a given reactant, if you have asked how many moles of alkyl halide you use, simply count the number of lone pair on the nitrogen and number of hydrogen. That means 1 lone pair and 3 hydrogen. If you take the examples from the 2 degree amine, number of lone pair on nitrogen, lone pair is 1 and hydrogen is 1. So 1 plus 1, 2. So that means alkyl halide used is 2. Moles of alkyl halide used is 2. Okay. Next our method is from reduction of cyanide. Basically, in amines we generally see the reduction reaction. At first our reactions were the reduction of nitro compound. Our next reaction is the reduction of cyanide. Reduction of cyanide. Third reactions will be the reduction of cyanide. Our next reaction is the reduction of cyanide. Cyanide, alkyl cyanide or nitrile. Cyanide is converted into 1 degree amine. Cn is converted into CH2 and NH2. Cn is converted into CH2 and NH2. Reduction of cyanide. Reduction of cyanide or nitrile. Reduction of cyanide or nitrile. Reduction of cyanide or nitrile. Let us take an example of cyanide. RC triple bond N is reacted with lithium aluminum hydride LiAlH4. LiAlH4. And the reaction is reduction. That means there will be the addition of hydrogen. The bond will be broken and two hydrogen, one hydrogen, two hydrogen at carbon and two hydrogen at nitrogen. The product will be RCH2 and NH2. That means our product is 1 degree amine. Our product is 1 degree amine. If you see the details mechanism, of the reduction of cyanide, it will looks like that. If we see the mechanism of the reduction of cyanide, at first cyanide, as we know that lithium aluminum hydride LiAlH4 is a source of H-, which we have already discussed in alcohol, phenol and ether. At first, lithium aluminum hydride LiAlH4 release H-. Due to difference in electronegativity del minus and del plus, H- will attach to del plus and the one bond will be broken and electron will be transferred to nitrogen, and our product, intermediate product, will looks like RCH and N. That means it is del minus. In the next step, here we take solvent molecules as water. In the next step, water molecules HOH, del plus, del minus. H plus will attach to del minus of the nitrogen, and our intermediate products will look like imine, CHNN. This is called imine. Okay. In the next step, lithium aluminum hydride will again release H-, and it is our del plus and del minus. It will again release at del plus, and our CH2 intermediate products will look like CH2 and H. That means it is del minus again from the water molecules, del plus and del minus. It will attack at NH2 and our product is CH2 and NH2. That means you can say that the two hydrogen added at nitrogen is from the water molecules. That means solvent. Two hydrogen is added from the solvent molecules. Hydrogen is added from solvent water molecules. and the 2 hydrogen is added from lithium aluminum hydride. 2 hydrogen is added from lithium aluminum hydride. That will the reduction of our cyanide in the presence of lithium aluminum hydride. In the presence of lithium aluminum hydride. Our next reaction is the reduction of amide. Our next reaction is the reduction of amide. Reduction of amide. Our fourth reaction is reduction of amide. Reduction of amide. Amide is basically reacted with, in the presence of amide is basically reacted with lithium aluminum hydride. Amide RC double bond O NH2 is reacted with lithium aluminum hydride. Lithium. This is also the reduction of amide. Simply we will here take the shortcuts to make the product. Our product will, the bond between carbon and oxygen will be broken. We will add 2 oxygen to the 2 hydrogen to the oxygen and 2 hydrogen to the carbon. H2O, water molecules will be released, and our products will looks like RCH2 and NH2. That means the 1 degree amine is also generated here. Our reduction of cyanide. In this reaction, reduction of cyanide or nitride, you can also take SN plus HCl or H2Ni. Here sodium borohydride is not used. Okay. Our next method of preparation of amines is Gabriel Thalamide synthesis of 1 degree aliphatic amine. From Gabriel Thalamide, we cannot prepare aniline because thalamide is reacted with aqueous NaOH and in the presence of alkyl halide and again KOH. Our amines is 1 degree amine, and the major step of the reaction is which alkyl halide undergo is SN2 reaction. If you take aryl halide as alkyl halide, then it will not again react with the substituted amide. So we only prepare 1 degree amine from the Gabriel Thalamide synthesis of 1 degree ammonia. And our next reaction is Hofmann bromamide degradation reaction, which is again from the amide. Amide is reacted with Br2 in the presence of 4 mole of NOH. Where alkyl isocyanate is formed, which on hydrolysis gives 1 degree ammonia. Okay, thanks.